today we'll look at the chain rule, which is a method for differentiating composite functions. So basically functions of functions. So if we consider this composite function of u, we can differentiate it by first differentiating the function with respect to u, and then multiplying that by the derivative of u with respect to x. So effectively chaining the derivatives together. And this can probably be seen better if we write the finite change in f with respect to x is equal to df du by du dx. Given that f is a function of u. And if we take the limit on both sides as delta x goes to 0, we obtain a derivative of f with respect to x is equal to the following limit. And we can split this up into two limits using the product rule for limits. And we can see that as delta x approaches 0, delta u also approaches 0. So therefore the derivative of f with respect to x, which is the same as dy dx, is equal to dy du by du dx. Let's evaluate the derivative of the following function, so we can observe it's a composite function. So we can write it as f is equal to cosine u, where u of x is equal to this expression. And now we can evaluate df du, which is minus sine u, and du dx using the power rule. And therefore df dx is the product of those two derivatives, which we are basically chaining together. So that's equal to minus sine u, where u is root x minus 2 on x, and that's multiplied by du dx, which can be simplified as follows.